In this module, you will learn about electronic configuration. During the arrangement of electrons in the shells, the outermost shell of an atom cannot accommodate more than 8 electrons, even if it has the capacity to accommodate more electrons. Generally, the outermost shell of an atom can have a maximum of 8 electrons only, even though it has the capacity to accommodate 18 electrons. This is due to the fact that having 8 electrons in the outermost shell makes an atom stable. There is an exception if the outermost shell is the first shell or K shell. The shell can hold only 2 electrons. For example, helium has only one shell in its atom. Electrons in an atom do not occupy a new shell unless all the inner shells are completely filled. The filling of electrons in an atom is a stepwise approach. First, the electrons are filled in K shell, then in L shell, M shell, N shell, and so on. There are few exceptions to this rule which are applicable to elements with an atomic number more than 18. After a series of experiments and a detailed study by scientists like Louis de Broglie, Schrödinger, Sommerfeld, etc., it was proved that shells have energy levels within them, and these are called subshells. These subshells are S, P, D, and F. Electrons are distributed in these subshells. Every subshell can accommodate a fixed number of electrons. The S subshell can hold a maximum of 2 electrons, a maximum of 6 electrons in the P subshell, 10 electrons in D, and 14 electrons in F. Electrons are distributed in their respective shells and subshells. The first energy level, K, can have one subshell, which can accommodate 2 electrons. The next shell is the L shell, which contains S and P subshells, where the S subshell accommodates 2 and P shell accommodates 6 electrons. M is the third shell and have S, P, and D subshells, which accommodates 2, 6, and 10 electrons respectively. Next is the N shell with S, P, D, and F subshells, accommodating 2, 6, 10, and 14 electrons respectively.
In this module, you will learn about valency. Let's observe the distribution of electrons in the given elements. Electrons in an atom are arranged in definite shells. The electrons which are present in the outermost shell of an atom are called valence electrons. From the octet rule, an outermost shell of an atom can accommodate 8 electrons. It was observed and concluded that an atom with completely filled subshells are stable and do not react easily. In other words, it means that the combining capacities are 0 or nil. The outermost shell of inert gas elements whose subshells are completely filled are stable. For example, helium and neon, where helium has 2 electrons in its outermost shell, and all other inert gas elements have 8 electrons. The combining capacity of the atom to form molecules, either with the same or different elements, is defined as valency. For example, elements like hydrogen, lithium, and sodium atoms contain one electron in the outermost shell. Therefore, they can lose one electron. So, their valency is 1. If an atom contains less than 4 electrons in its outermost shell, the valency of an atom is equal to the number of electrons present in the valence shell. For example, aluminium has 3 electrons in its outermost shell. So the valency of aluminium is 3. On the other hand, if the outer shell has more than 4 electrons, the valency is 8 minus the number of electrons in the outer shell. For example, chlorine atom has 7 electrons in the outermost shell. Here, in this case, it is easier for chlorine to gain 1 electron instead of losing 7 electrons. Hence, its valency is determined by subtracting 7 electrons from the octet, which gives the valency of 1 for chlorine.